Hello, welcome to section 1.2 of our intermediate algebra class. So exciting. So we are talking about integers. So let's get into it right here. And we're going to go through all the operations and all that super fun stuff. Okay, so first of all, what is an integer? Suppose you have the number line here. We know that the positive numbers are to the right of 0 on the number line, right? And the negative numbers will be to the left. And the negative and the positive numbers plus, and also mean including 0, these are the integers, okay? Integers are, all the negatives and all the positives and including 0. Let's also define the term opposite, okay? The opposite of a number is a number that's the same distance from 0. We know that the opposite of 3 would be -3. The opposite of -5 is +5, yeah? Okay. Now let's talk about absolute value. Now absolute value is defined as the distance away from 0 on the number line. So the absolute value of -5 is 5 units away. Distance is positive today. So that's why when you see an absolute value, a negative inside of it, it becomes positive. Because what the absolute value sign is telling us, hey, this -5 is 5 units away from 0. Okay, so now let's go through some simplification, right? So let's do some comparing here. So let's say you have a absolute value of -5 and you want to compare it to the negative or the opposite of the absolute value of -5. So if I simplify this becomes 5. This part right here becomes 5, but the negative doesn't change. So this is actually -5. So this would be greater. Okay, so for B, you have 8, and then you want to compare it to -8. Okay, so notice that the opposite of absolute value is different, than the opposite of an opposite. These are two different things. One, this is a straight line, and this actually means -3. And this one here, this is an opposite of an opposite, so it's a positive, okay, 3. So they're different. Straight lines versus parentheses. Okay, so this one here, this one's bigger. For C, you have -9, and on the other side, you have -9. So they're actually equal. Here you have, okay, this becomes a +16. And then on the right, this actually becomes 16 also because it's the absolute value of -16, so these are equal. Okay, so now we can add something to our grouping symbols. We can add absolute value. It's a form of grouping. Okay, just like how parentheses, right? PEMDAS. Okay, so here we have 24 minus the absolute value of 19 minus 3 times the quantity 6 minus 2. So first we group inside here. And then from within here, we prioritize this, right? So everything else I'm going to leave the same, right? And then the first thing I'm going to do is within this parentheses, this is a 4. Okay, now I do this again. The outside stays the same. 19 minus, multiplication first, so this would be 12. So 24 minus the absolute value of 7, which is just 24 minus 7, which is equal to 17. Okay, all right. So let's talk about integers, right? We know that the whole numbers and their opposites are called integers. Now we're going to talk about adding and subtracting. So before we do that, we also need to notice that when you have a subtraction, expression, you can write it as an addition by saying that the number is being added, its opposite. So instead of saying A minus B, you can also think of it as A plus a -B, and they're equivalent. Okay. So the book goes into using these counters and all of this to describe adding and subtracting integers. I don't do that. It's just easier to remember it together, to learn it together. So when you want to add or subtract integers, when do you know when to add or when to subtract? Well, that's easy. You just look at the signs. So let's say here you have 3 plus 5. Well, these are two positive numbers. They're both positive, so I'm going to add them together. And since it's positive, it's going to stay positive. That's going to be 8. So same signs add. So let's do another example. So -2 minus 7. That's equivalent to, right, adding -2 plus -7. So that's just, you add these two numbers. They're the same sign. I can add them together, but I keep the sign, so it's -9. Okay, so same signs add, but you keep the sign. And now if you have different signs, you subtract. So let's say you have 5 minus 3, subtract them. It's 2, the larger number, keep the sign of the larger, so that's positive, so it's +2. But if you have 3 minus 5, well, the difference between 3 and 5 is 2, but, between 5 and 3, so you subtract larger minus bigger, but you keep the sign of the larger. So since 5 is the larger number, it's a -2, okay? All right, let's do some more super fun examples. So here we're adding same signs, right? Add. So that's 5, but we keep the sign, so that's -5. So B, these are different signs. We're subtracting, that's 4. Keep the sign of the larger, that's positive. Okay. Here, 1 plus -5, so subtract, that's 4, but you keep the sign of the larger, so that's -4. Okay. So here, for this one down here, 3 minus 1, that's just 2. You keep the sign of the larger. You can rewrite this as -3. Opposite, that becomes +1. So these are different signs, so you subtract. Right? But which one do you keep? What sign is it? It's -2 because it's -3 plus 1. Okay. That's that for B. Now for C, these are the same signs. So we add them, but we keep the sign. So it's -4. For D, this is 3 plus 1, same sign. We keep it, we add it, and we keep the positive, right? Okay. So I think we've done enough of those. So you can check these. I think the answer's in the book. Let's do one more. So here we're going to do inside the parentheses. So 7 minus, same signs add, keep the sign. So -7 minus 9. So then this becomes plus. 7 plus 7 is 14 minus 9. That's equal to 5. Okay, so now let's talk about multiplication and division. So multiplying and dividing. So if you have two positives, some positive number times a positive, that equals a positive. If you have a negative times a negative, that's also equal to positive, okay? Now, if the same signs are the same, the answer is positive. This is different than adding and subtracting, okay? It's multiplication and division now. If you have different signs, a positive times a negative, your answer will be negative. And if you have a negative times a positive number, the answer will still be negative, okay? All right. So if the signs are the same, the product is positive. If the signs are different, the product is negative. So here you have, and that goes for division as well. So you have -100 divided by -4. That's -100 divided by -4. That's just 25 positive, right? For B, 7 times 6, what is that? 42. That's it. C, 4 times a -8, that's -32. D, 27, -27 divided by 3, that's 9, but it's negative. Okay. Okay, also worthy of note, when you multiply by -1, you get the opposite. Now, you just have to be careful when you're dealing with exponents. So notice the following: -2 to the 4th power. That is, this exponent applies to the entire -2. So if I was to write this out, it's like I'm saying -2 times -2 times -2 times -2 times, right? So 16, because you have these these all become positive. So your answer would be a positive 16. In fact, anytime you raise a negative number to an even exponent, your answer will be positive. That's because the negatives pair up and become pluses. Okay, so what about B though? You have negative to the 4th. So what that actually is, you're saying the opposite of 2 times 2 times 2 times 2, right? Because this exponent only applies to just the 2, not the negative. So this will be -16. Okay, so interesting. They're different. So make sure you're aware of that. Okay, let's do some more examples. Here we have 8 times -9 divided by -2 cubed. So basically it's 8 times -9 divided by -2 cubed. That's 8 times -9. That's -72 on the top, and on the bottom is -8. So final answer, positive 9. Okay, what about B? You have 30 divided by 2. Half of 30 is 15, but it's negative, right? And then you're adding the product of these two. That's 21. So then your final answer is 6. Okay, and then let's do an evaluation problem where you plug in 2 for x and -1 for y. So we're basically having 4 times, instead of x, we're going to put a 2 in parentheses squared, minus 2 times, instead of x, I put a 2, instead of y, I put a -1, plus 3 times -1 squared. Okay, so let's figure that out. This is going to be 16, because 2 squared is 4, 4 times 4 is 16, minus, or plus, right? 2 times 2 is 4 times -1. This negative times this negative makes it a positive 4. And then plus -1 squared is just positive 1 times 3, so plus 3. Final answer, 23. Okay, let's do a little bit of translating phrases to expressions with integers. The sum of 8 and -12, let's translate that. So that's the sum, which is increased by 3. So you have 8 plus -12, that's -4. Then you're adding 3, so that's -1. Okay, so now here we have the sum of -8 and -12, and it's increased by 7. So that's on the outside there. So this is going to be -20 plus 7, which is -13. All right, so that's it for section 1.2. You did it. You can do odd or every other odd, so it depends on how much time you have and how much practice that you think you need, okay? Good luck, and I will see you on the next video.